Okay, today we're going to be talking about types of reaction. And so when we dive into this first, there's going to be a little bit of introduction to chemical reaction. So anytime a chemical reaction takes place, we are going to have a transfer of energy. And that energy is going to cause reactions to be exothermic or endothermic. Now, with exothermic, energy is leaving the reaction. Okay, it's leaving the system. So exothermic is heat is being released. All right, but it could also be light in general, energy leaving the system. Think about hand warmers. You crack them. As that reaction is taking place, we're giving off heat. All right, there are plenty of reactions that we're going to do or that we have done that you can touch the beaker and it gets a little hot. Okay, I believe when we mix the calcium and it made that pink, you could touch that and that was a hot beaker. Okay, that'd be exothermic. Then endothermic is that energy is entering the system. It is absorbing energy, absorbing heat, and so therefore it feels cold. Instant cold packs. Snap those and it feels cold. There, it's absorbing heat, which is why it feels cold. All right, so there are five main types of reactions. There's synthesis, decomposition, single replacement, double replacement, and combustion. All right, synthesis is also known as combination, and so we'll get into that. All right, so in synthesis, two or more substances are going to react and they're forming one new compound. So the easy way to figure this out is that on the left-hand side, you're going to see where there are two distinct elements or two compounds. And when they are reacted, they're going to form one single product. And our example would be magnesium and oxygen making magnesium oxide. Now, all of these are going to have a video link to give you examples, but they're each a minute long, and I'm not going to make you watch it on here. All right, the slideshow is on the classroom. Feel free to pop on there and look at those reactions. Okay, now, next up we have decomposition, which is just the exact opposite. So we have a chemical change in which one single compound is going to break down into many products. It could be two, it could be three, it could be four. Doesn't matter how many. It is decomposing one single reactant, many products. So here we're looking at copper carbonate, and it will be heated and then form a copper oxide and carbon dioxide. And you'll be able to see gas being given off. Eventually, some liquid gets put in there, and there's bubbling. Okay. In this, there's a process that you can make mercury that's similar, where you have a mercury oxide, like a white powder, and you heat it up, and the oxygen is given off into the air, and what you're left with is pure mercury, that liquid silver, liquid metal. All right, now we get into the slightly more complicated, but not really, reactions. And there are single replacement and double replacement. Now, in a single replacement, all right, what you have is that one element replaces another element in a compound. So there is one singular element and one compound, and the element is going to rotate in. All right, it's going to rotate in and kick out the one. So A here is going to come in and kick B out. And now B is over here by itself. Okay? And so in this, you have one single thing coming in and kicking out another. A single is replacing. All right? And what you see over here is that there is a silver nitrate solution and a copper rod. And what's going to happen is the copper is going to go into solution, forming copper nitrate, and the silver is going to attach itself to this coil, which is why you're starting to see that silver color. All right, that'd be single replacement. All right, now with double replacement, just a little bit different. What we're going to have is that instead of it being a single chemical rotating in, you're going to have where they exchange partners. So there's two sets of compounds. And so what'll happen is you'll switch partners. Okay? Imagine you're playing a game and you end the round and all of a sudden you switch partners. All right? Or in this reaction here, you have where iodine is going over to be with lead, nitrate is coming over to be with potassium. All right, and you'll see that there. This is a bit of a cool reaction. And so you'll see instantaneously swapping. All right, two clear liquids prior. And you'll see what happens when they mix if you decide to watch. All right. But a double replacement is you exchange partners. So instead of having a single thing come in and kick out a single thing, you have two partners switching. All right. And so there's a nice little summary chart here that shows it, illustrates it. Okay. But the easier one to view might be this one here, right? A little Star Wars for you. But in synthesis, you have where they are separate and then they come together. In decomposition, they are together and then they separate. In single replacement, you have one thing together, one thing separate, and the one thing will rotate in and kick out the other. And then in double replacement, you have where they will switch partners. All right. And so that leads us to our last but not least, combustion. And combustion you've heard of before. It is a fairly simple one to comprehend, which is that it involves oxygen. It's a chemical change which anything really, but we're going to mostly see hydrocarbons. They react with oxygen. The key is that O2, this oxygen gas, is always one of the reactants. So it'll be like this by itself on the left-hand side as one of the reactants. It's not going to be with anything. It's going to be just O2 as the reactant. And so in this case, we have methane plus oxygen. And if we have that, you'll get carbon dioxide and water as products. That doesn't have to be the product. Sometimes it'll be mixed with oxygen. It'll be a nitrogen compound. But nonetheless, something plus oxygen, O2, goes to form CO2 and H2O. And what we get is this classic little reaction that you're used to, right? And so she's putting in some of this hydrocarbon there. Okay, ethanol, I think is what she's putting in there. And so let's see. She's going to go ahead and turn out the light. She's going to add some fire to start it. And you see, there it is, combustion. Nice and easy, exactly what you see. There are 5 types of reaction.